Hi Algebra 2, this is Unit 6, Lesson 2, and today we're going to do a review of factoring. So this is something you probably did back in middle school, you did it in algebra. Factoring is super important to know, so that's why we're taking the time to review it right here. Factoring really just means that you're rewriting an expression as multiplication. Okay, there are two definitions right here. As a verb, factor means to rewrite a quantity as an equivalent product, product meaning multiply, or as a noun, any individual component of a product. All right, so we factored before integers, you factored algebraic expressions, and we're going to review all of that factoring right here. So we're just going to take a number 12, and I want to write factor completely means that I want to write it as a product of only prime numbers. All right, so if I think about it, 2 times 6 is 12, and then I can factor this 6 one more time, it's 2 times 3. So 2 times 2 times 3 would be my answer. Those are all prime numbers. So those factors multiply to give me 12. 30, I can say 2 times 15 is 30, and 2 is a prime number, and then I'm going to break down my 15 to 3 times 5. So 2 times 3 times 5 is 15. And 16, I'm going to say 2 times 8 is 16. And then I can break down the 8 to 2 times 4. And then I can break down the 4 to 2 times 2. So basically it's 2 times 2 times 2 times 2. Those are the prime factors of 16. All right, keep in mind that when you're factoring, you're just rewriting it in a different form, but the answer is equal to the original. All right, it might look different, but 2 times 3 is still the number 6. All right, let's rewrite each of the following binomials as a product of an integer with a different binomial. So I'm going to factor out, I'm going to say what is the greatest common factor of 5 and 10? Well, 5 is, and I'm going to pull that 5 out. Basically, you're going to divide it out. When I divide out that 5 from 5x, I'm left with x. When I divide out the 5 from 10, I'm left with 2. So that's my answer right there. You should be able to remultiply it and get the original. If I was to distribute 5 times x is 5x and 5 times 2 is 10. All right, so you can do like a quick check in your head. 2x minus 6. So say to yourself, what's the biggest common factor that both of those terms have in common? A 2. And when I factor out a 2, I'm left with x. And then the negative sign stays. When I factor 6 divided by 2 is 3. Again, you can multiply it quickly in your head just to make sure that it equals 2x minus 6. And 6 minus 14x, the biggest common factor is 2. When I factor out a 2, I'm left with 3 minus 7x. Let me close that parenthesis there. All right. So the above type of factoring is often referred to as factoring out the greatest common factor, and we call that GCF. The greatest common factor can be comprised of numbers, variables, or both. So factoring by GCF. GCF, greatest common factor, is a number or expression that can be divided into each term evenly. It is a number or expression that can be undistributed to every term in a problem. And there are two examples right here, a little bit more complicated than the ones that we did, because not only was there a number in common, but there was also a variable in common, that x. Okay, so when I looked at this first expression right here, the biggest number in common was 4, and the biggest variable in common was x. So I factored out that 4x, and then what's in parentheses is just what's left. All right, so let's practice some that are a little bit harder because they're going to have a number and a letter that I'm going to factor out. So we got to look at the numbers first. 3 and 6, biggest common factor is 3. X squared and x, the biggest common factor is x. When I factor out a 3x, I'm dividing out a 3x, I'm left with x. And when I'm dividing out a 3x from 6x, I'm left with 2. You should be able to distribute this and get back the original. So that's like a quick little check for yourself to make sure that you did it right. You can multiply it back to get that original expression. B, 20 and 5. Well, the biggest number is 5 that's in common, and they both have an x. Okay, I can only do what they both have in common. When I factor or divide out a 5x from 20x, I'm left with 4. And when I factor or divide out a 5x from negative 5x, I'm left with negative 1x Or you could just write the x. You don't have to write the 1. And then 30x squared minus 20. The biggest number they have in common is 10. And there is no letter in common. So when I factor out a 10, I'm left with 3x squared. And negative 20 divided by 10 is negative 2. All right, so here's a multiple choice. We want to rewrite each of these, and we want to rewritten in factored form. So actually, you can just take these and test them out to see which one would give me 20x squared minus 36x. Like 9x times x is not giving me 20x squared. All right, 4x times 5x gives me 20x squared. 4x times negative 9 gives me negative 36x. Oh, there it is. I got it right off the bat. All right. The other ones were good. They were giving me 20x squared, but they were not giving me the negative 36x. All right, trinomials. So trinomials can be also factored into the products of a GCF and another trinomial. Rewrite each of the following trinomials as a product of its GCF and another trinomial. So whatever we're factoring, you're always looking to see if there's a greatest common factor. So 2, 8, and 10. Greatest common factor is 2. I got x squared, x, and nothing, so I cannot factor out an x. So I factor out that 2, and I'm left with x squared plus 4x plus 5. Okay, remember that you are just looking for the greatest common factor, and you're dividing that out. 10x squared minus 20x plus 5. Greatest common factor is a 5. So I'm dividing out a 5, and I get 2x squared. Negative 20 divided by 5 is negative 4x, and 5 divided by 5 is 1. You do need that placeholder there, that 1. 8x cubed minus 12x squared plus 20x. So this, all the numbers 8, 12, and 20, the greatest number they have in common is 4. And I got x cubed, x squared, and x, so I can actually factor out an x. So I'm going to divide out a 4x, and I'm left with 2x squared. Remember, when you're dividing, you're subtracting those exponents. Negative 12 divided by 4 is negative 3. Again, subtract those exponents. And 20 divided by 4 is 5, and x, they cancel out. And that's my answer. So this is a review of all the different kinds of factoring that you did back in algebra and in middle school. So a perfect square is any number or expression, okay, that has basically 2 equal integers as its factors. 2 equal integers as its factors. So example like 1. 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square. 3 times 3 is 9. Not only numbers, but also even exponents. X times x is x squared. X squared times x squared is x to the 4th. So I have to have 2 equal integers as its factors. And we can always factor the difference of 2 perfect squares as conjugate pairs. Okay, so conjugate pair means that you're really just changing the sign between the 2 terms. It's the exact same factor, like x squared minus y squared factors to x plus y and x minus y. So it's the exact same factor, but the sign is different between them. So you're changing the sign between the 2 terms in a binomial. So you're changing the sign between the 2 terms. Okay, so this is a difference of 2 perfect square. Difference of 2 perfect squares. That's the next factor. You're going to remember it as soon as I show you a problem. All right, so if I have x squared minus 9, as long as they're both a perfect square. All right, so x squared is a perfect square and 9 is a perfect square. So I set up my 2 sets of parentheses. X times x is x squared. 3 times 3 is 9. 1's a plus, 1's a minus. And that's your answer. The difference of 2 perfect squares. They both have to be a perfect square. 16 is a perfect square, 81 is a perfect square, and x squared is a perfect square. So 4 times 4 is 16. 9 times 9 is 81, and x times x is x squared. So this is going to be 9x times 9x is 81x squared. 1's a plus, 1's a minus. Because if you were to multiply these out, remember, you can always check by multiplying them. All right, remember FOIL, first, outers, inners, last. If I was, let me do it with the easier one. If I was to multiply this out, x times x is x squared, x times negative 3 is negative 3x, 3 times x is positive 3x, and 3 times negative 3 is 9. You always get 4 terms, but those 2 middle terms are going to cancel each other out. And the last one, again, difference of 2 perfect squares. 2x times 2x is 4x squared. 5 times 5 is 25. One's a plus and one's a minus. So that's the difference of 2 perfect squares. Same thing works with a fraction too. All right, so we're going to look at a fraction right here. They are still the difference of 2 perfect squares. So 2/9 times x times 2/9 times x is 4 over 81x squared. And 7/3 times 7/3 is 49 over 9. One's a plus and one's a minus. All right, just to show you a little bit different one. And I can also have 2 sets of variables, x squared and y squared. So 6x times 6x is 36x squared. And 7y times 7y is 49y squared. One's a plus and one's a minus. It does matter which one goes first. Okay, whenever we're factoring, we want to factor completely. The first step is to look for the greatest common factor, and then you see if there's anything else you can do afterwards. So on number 8, so first I'm going to factor out the greatest common factor, which is going to be 5. When I divide out of 5, I'm left with x squared minus 4. Now this right here is the difference of 2 perfect squares, so that can be factored one more time. So the 5 hangs out in front. I set up my parentheses. X times x is x squared. 2 times 2 is 4. One's a plus, one's a minus. And the 5 is just hanging out in front. B, the greatest common factor is actually a 7. And I'm going to have 4x squared minus 1. Now this is a little bit tricky, but these are the difference of 2 perfect squares because 1 times 1 is 1. So the 7 hangs out in front. 2x times 2x is 4x squared. 1 times 1 is 1. One's a plus, one's a minus. And in C, I'm going to, the greatest common factor, look at the 3 and the 48. So 3, but I also have a letter I can factor out. I can factor out an x. Both of those expressions have an x. That leaves me with x squared minus 16. And hopefully you recognize by now, this is the difference of 2 perfect squares. So 3x is hanging out in front. X minus 4, x plus 4. It doesn't matter if you write the plus or the minus first because you're going to have one of each. Okay? And that was it. Tomorrow we're going to do a little bit of factoring by grouping, but we're going to practice this first. Again, this is all just a review of what you should already know, but factoring is super important, so we want to make sure that everybody's okay with it. So we'll practice that tomorrow.